Download this code from codegive.com, link in the description below. OK, let's dive into a deep and detailed tutorial on code organization within the chillicream GraphQL platform, specifically addressing the considerations raised by issue 196, or relevant points about structure and maintainability based on the discussion in that issue, assuming it covers common problems. We'll focus on best practices, code examples, and strategies to ensure your hot chocolate GraphQL APIs are clean, scalable, and easy to maintain. Understanding the core principles. Before we jump into the code, let's establish some guiding principles. Separation of concerns. Divide your code into logical units, each responsible for a specific aspect of your GraphQL API. This could be based on features, example authentication, user management, product catalog, data access patterns, example repositories, data loaders, or Graphql-specific constructs, example types, resolvers. Single responsibility principle, SRP. Each class or function should have only one reason to change. This makes your code more modular and less prone to unintended side effects when you modify it. Don't repeat yourself, avoid duplication. If you find yourself writing the same code in multiple places, refactor it into a reusable component. Convention over configuration. Establish consistent naming conventions, directory structures, and code formatting. This improves readability and reduces cognitive load for developers. Testability. Design your code with testing in mind. Use dependency injection and interfaces to make it easier to mock and test your components. Scalability. Organize your code to be easily extensible and maintainable as your API grows. Hot chocolate specific best practices. Leverage hot chocolate's features like object type, interface type, union type, data loader, and resolver to organize your GraphQL schema and resolvers in a structured manner. Assumptions about issue 196, and typical concerns. Since I don't have the specific content of chillicream's GitHub issue 196, I'll assume it revolves around these common problems related to code organization in hot chocolate projects. Monolithic startup.cs. The startup.cs file, or equivalent in newer .NET versions, becomes a dumping ground for all GraphQL configuration, making it difficult to read and maintain. Scattered resolvers. Resolvers are defined in random places, making it hard to find and understand the data fetching logic for specific fields. Tight coupling. GraphQL types and resolvers are tightly coupled to specific data access implementations, making it difficult to switch data sources or test the API in isolation. Lack of abstraction. Data access logic is mixed with GraphQL resolver logic, making it hard to reason about the system's behavior. Repetitive code. Similar resolver patterns are repeated across multiple types, leading to code duplication. Proposed directory structure. Here's a recommended directory structure for a moderately complex hot chocolate GraphQL API. Code examples and explanations. Let's illustrate these principles with code examples. I'll use C with .NET and hot chocolate. 1. Models. 2. Data access, repositories and data loaders. 3. GraphQL types. 4. Queries, mutations, and subscriptions. 5. Startup configuration, program.cs or startup.cs. Key takeaways from the code. Types as schemas. The user type and order type classes define the GraphQL schema for your data models. Use descriptions extensively to document your API. Asterisk resolvers for field logic. Asterisk resolvers handle the logic of fetching data for specific fields. Note the separation into separate resolver classes. Asterisk data loaders for efficiency. Asterisk user by ID. Data loader optimizes fetching users by ID, avoiding the n+1 problem when resolving relationships. Asterisk dependency injection. Asterisk the iUser repository is injected into the user by ID data loader, making it easy to mock and test. Similarly, the DB context is injected where needed using scoped service. Asterisk DB context management. Asterisk using used DB context attribute handles the creation and disposal of database context within the scope of the resolver. This attribute takes care of creating a DB context, injecting it into the resolver method and disposing it after. Asterisk inputs and payloads. Asterisk the create user input record and create user payload are used for mutations to cleanly define input arguments and the return data structure. Asterisk paging, filtering, and sorting. Asterisk the use paging, use filtering, and uses ordering attributes on the get users query automatically enable these features in your GraphQL schema, leveraging Hot Chocolate's built-in capabilities. Addressing the issue 196 concerns, hypothetically. Based on the assumed concerns of issue 196, here's how this code organization helps. Asterisk splitting startup.cs. Asterisk instead of putting all GraphQL configuration in startup.cs, create extension methods in the GraphQL/extensions folder, example service collection extensions.cs, to register your types, resolvers, and middleware. This keeps startup.cs cleaner. Asterisk centralized resolvers. Asterisk all resolvers are organized into the GraphQL/resolvers folder, grouped by the type they resolve fields for. Asterisk loose coupling. Asterisk by using repositories and interfaces, the GraphQL layer is decoupled from the specific data access implementation. You can easily switch data sources or mock the repository in tests. Asterisk abstraction. Asterisk the business logic is separated into services and repositories, keeping the GraphQL layer focused on schema definition and data presentation. Asterisk dry. Asterisk use base classes or extension methods to encapsulate common resolver patterns. For example, you could create a base class for resolvers that need to access a specific repository. Further considerations. Asterisk authorization. Asterisk implement a consistent authorization strategy using Hot Chocolate's built-in authorization features, example policies, claims. Consider creating a separate authentication folder in services to encapsulate authentication logic. Asterisk error handling. Asterisk implement a global error handler to catch exceptions and return meaningful error messages in the GraphQL response. Hot Chocolate provides mechanisms for custom error formatting. Asterisk schema stitching. Asterisk if you have multiple GraphQL APIs, explore schema stitching to combine them into a single, unified API. Asterisk federation. Asterisk federation is an advanced approach to building distributed GraphQL APIs that allows teams to independently develop and deploy parts of the API, which can be combined into a single, unified graph. Asterisk documentation. Asterisk use XML comments in your code to generate API documentation using tools like Swashbuckle, for REST APIs, or similar solutions for GraphQL. Testing. Asterisk write unit tests for your resolvers, data loaders, and services. Use dependency injection to mock dependencies and verify that your components behave as expected. Consider integration tests to test the entire GraphQL API end-to-end. Example test, using XUnit and mock. In conclusion. Asterisk organizing your Hot Chocolate GraphQL API is crucial for maintainability, scalability, and testability. By following the principles of separation of concerns, dry, and convention over configuration, and by leveraging Hot Chocolate's features, you can create a clean, well-structured API that's easy to understand and evolve over time. Remember to tailor the directory structure and code examples to your specific project requirements. Pay close attention to dependency injection, data loading, and resolver organization to ensure optimal performance and testability. Regularly review and refactor your code as your API grows to maintain its quality. Always keep the assumed context of issue 196 in mind while implementing these practices.